Okay, so we're going to review the Terraform code. I'm going to go ahead and pull that up now. And this is the Terraform code that we're going to look at for AWS. First of all, in main, var region, or region is set to var.region. We're going to talk about that in a moment. You see, we set the required Terraform version as greater or equal to 1.2.5. I had to comment this out because if I specified the AWS provider, Terraform init would fail. But then when I didn't specify, it would go ahead and download 4.18.0. I cannot explain why. Now here, this is in 001 main.tf. You see we've got backend S3, and you're going to replace the bucket name of Kent Cloud AZ DevOps with the S3 bucket that you just created. So if you could open up Visual Studio Code and do that now, I would appreciate it. So going on to the next piece of code, you see that we have this file called 005 variables. And if we look here, we could see a number of variables have been created. You're going to have headaches because you selected a region other than East US 1. Okay. Yeah, you might have to destroy and recreate the S3 bucket. So you could see that we have defined the region here. It's a string, and I give it a simple description. And look here, we have these availability zones that I've picked. You'll note I have a comment in the code. You may need to select different availability zones based on available capacity. There's no guarantee here. There are several availability zones within each region. And there are moments in time where capacity runs out in one zone versus another, and it's trial by error. I don't know if it just happened to be that AWS was running low on capacity when I was initially building this out. But during that week that I was spending doing this, it was very problematic. So I point that out because it's been very stable lately, but it may not be stable again in the future. But more importantly, this could impact what you do in the real world in AWS. Now, you might be wondering, why am I defining all of this? Well, that's because the the AWS module requires it to be defined. If I don't pass it these values, the module will fail when I run a Terraform validate. It'll give me an error. And it took a while to figure that out, and it took a really long time to get this code to run. So I've got a project name, and here for platform type, this is a tag, and I put in managed by Terraform. And this is an important practice when you stand up infrastructure in the cloud, you want to, and you're doing it with Terraform, you want to tag each resource as managed by Terraform. And you also want to tag it as to whether this is development or test. I'm sorry, development or production, what the environment is. That's just a good practice so that other people who follow behind you, as well as yourself, when you step back into the code, if something needs to be modified, you can look and see what it is you did. And if you're looking at something quickly in the console, or if it's Azure in the portal, that you can quickly tell this is a resource that's managed by Terraform, or this is a resource that is not managed by Terraform. I'm sorry? That is a tag, yes. Now, I will tell you that if you manage a resource with Terraform and you go in and make changes to that resource using the console, the same is true in Azure with the portal, and you then go and later run this Terraform code, depending on the type of resource, there may or may not be an impact to whether or not your Terraform code will run again. This is particularly the case with complex things like SQL in the cloud, or Kubernetes service in the cloud. If people go tinkering with that outside of Terraform, once it's managed by Terraform, they're going to break it. And then when you even go in to make a simple non-related change, let's say there's a VCN in there that you need to change that's next to the cluster in the same resource group, and you try to run your code and it fails. And that's not nice, because it's not nice to have to tear down and rebuild an AKS cluster, especially if it's production. On the other hand, you should be treating even your Kubernetes clusters as disposable objects. If you've written the code to define them and somebody mucked it up, then you should be able to go in during non-business hours, if it's non-critical, and destroy and recreate the cluster, and then push out the pods. And the application should come right back up where it left off. If you've done your job right, that's how it works. Remember, we're agile. The cloud is very pliable. We just need to know how to play with the Play-Doh. I think this is very straightforward, where we've got these variables and what they are. You see, I'm even defining a memory var for a user here. I don't know how to do user administration in AWS using the console. I know how to with Terraform, though, using the modules. That's how interested I am, or rather uninterested I am, in the AWS console. I dislike it that much. Now here in network, you see that I've got two things here. I've got a commented out section here called ... modules. This is where I cloned the module down. However, what I ended up doing was, once I figured out the version, because when I cloned it down, then I managed to change a car in one of the files by mistake when I was looking at the code. And so I wasn't happy about that. So I just commented that out, and I did a little more research to find out how I could pin that. And the way I pin the version is I go to the GitHub site where that module was published by AWS, and I looked at the pull history, the Git pull history, the same way you would do with your own GitHub repositories. And I was able to find the tags there. And that's how I was able to pin it. Now, again, with Terraform, the executable Terraform, I haven't figured out how to get old tags yet. They've hidden that really well. I can only get the latest, so I keep those, the Ubuntu version of those on my desktop, so I can run Terraform in a container when I need to. And that is true when I do the Azure CLI, when I'm doing Azure terraforming. That's how I do that. Here's where I'm creating the user, and you see this actually is going to download the AWS module for IAM, specifically IAM account, and this specific version to create the user. And you see you have to specify a minimum password length, but if you don't set a password on the account, then no one's going to log in with that account. And I don't recommend setting passwords on AWS accounts that are used for services. You should be using API keys. This is the user account that would be associated with this AWS cluster, and then you'd have to set up an API key and then do some magic to get to use kube control. That's the CLI for Kubernetes. You would need that API key as part of setting up kube control so that you could manage the cluster after you create it. We will not be covering that today. That's outside of scope of today's training. The next thing, we've got this piece of code here that creates the Kubernetes cluster service. And you see I'm pinning the version, I'm specifying the source module again. This is how you do string concatenation in Terraform. Again, you're going to get the beginning knowledge of what you need to write Terraform code, but this is not going to teach you how to write Terraform code. It's an introduction. Again, connect to me on LinkedIn, and then I can go ahead and get you those training courses. I don't have a good training course in terraforming in AWS. I didn't like anything I saw to date on Udemy. So you can see we've got the cluster name. This is the version of Kubernetes that is deployed. That increments pretty quickly. And then that's for making it privately accessible to the VNet. That's for making it publicly accessible. Obviously, if you set both of these to false, you'd have a cluster and you wouldn't be able to manage it. And then I don't know what this means. I just know that if you don't have it, it breaks. And this is for a local network interface. It's required for the cluster when you enable private access to the cluster. And here this is how you reference the name, the ID of a resource in the Terraform state file. I don't have time to go into great detail. Again, I'm going to refer you to the training after you connect with me on LinkedIn. This is the only hard-coded IAM role, and this is a predefined role. I don't claim to be strong in AWS IAM roles. I haven't done enough of IAM in AWS to be strong. Usually I work with a client who already has trained up people in AWS, and they tell me, you will put this in as the roles when you build the cluster. This is the name of the node pool. They call them node groups. Everyone else calls them node pools. And you see I have mixed instance types here. So you see blue is empty, it's not defined, green is defined. And this one is capacity type is when we need it, build it, but give me at least one. In production, you would dare not do one as the minimum, because then you would have a single point of failure in your infrastructure. That'd be a resume writing experience. So in production, you would set your minimum size to at least 3 or more, depending on your workload requirements. And then you can see we're defining the instant types, which is a list, and you could provide different types in your list. Then we're doing the role assignment, the user assignment, and recall these roles were already defined in the code. And I'm not familiar with Fargate, so I just accepted the defaults. And then here is where we apply the tags. Finally, none of this would be complete without the container registry, because the Kubernetes administrator, the application developers who are pushing out application pods onto the Kubernetes cluster will need a registry to write the container images to. And so that's how we do that there. You'll note that here I am not using a module, whereas here we were defining module. Module is a reusable set of code that will actually call the resource plugins from the plugin provider, in this case AWS. But remember our earlier discussion, the AWS plugins are very complicated, and you have to write lots and lots of code to do simple things. And AWS's answer, instead of rewriting the plugins to be easier, they used modules instead, and that was their solution to it, at the price of losing some flexibility. So in this case, since the container registry plugin is really easy, there's not much to do with it, I was able to, just define this here directly. And how did I get this? Well, it was a matter of exploring it, the actual pages. So if I go here and do a web search on that, and now I'm actually on the Terraform website, and I can see how to use that module. This does not tell you anything about how AWS Cloud works. So if you've not taken the basic courses, which are free, again, they're free. If you've not taken the basic online courses and how to use AWS, how to use OCI, how to use Azure, and you start terraforming, you're going to go nowhere fast. You will be stuck in the mud. You really must begin with learning the cloud provider and then doing the terraforming. Otherwise, you won't be able to connect the dots. Now here in the modules, that's where I actually clone those modules, because I had to actually go here and I had to figure them out. They've got a README MD file, but and this is all viewable off of GitHub, but they weren't helpful. I had to go to the code myself and read it and analyze it. And you see it's not small. And you see how the module is using resource. And then you've got things like this. And I assure you, when you go in, if you want to play with this and you modify them, it's just a setup for failure. Because you change one character gets changed, and you don't know where that value is being used elsewhere in the module. And it can be very frustrating to try and reverse engineer that. But that's the code in the modules. So now we're going to go to the next lab exercise. And in the next lab exercise, we're going to create this AWS infrastructure from the running container instance. Remember, it's going to create Terraform state information, and it's going to save that state information in the key file associated with the service user you just created. That will not be what you define for Azure DevOps. So this is infrastructure that we're going to build and throw away. You'll begin by running Terraform init. You do that upgrade is --, but again, this go figure, right? You use the ---- upgrade if you want to make sure that your Terraform modules are consistent with what your code is defining, and that if anything is changed, that change is applied. When you're using modules that download from the provider site, every time you do, when it's a new day, because typically these code updates push at night, every time that you start in the morning with AWS, do a Terraform init upgrade. Do it every time. The reason is you want to capture any changes in state. Otherwise, your code may not actually run successfully to completion without errors. Terraform validate is a syntactical check. That's all it is. Terraform plan actually tells you what Terraform will do. Not shown here is out, which creates an out file. I don't use out files. There are reasons to use out files. There are reasons not to use them. The Terraform training will help you to understand when to and when not to. Terraform apply applies the changes to the Terraform state into the subscription, and Terraform destroy destroys everything that is managed by that Terraform code. You can be selective with Terraform destroy, but I think that's a dumb way to handle it, where you do Terraform destroy and then the actual Terraform resource that you wish to destroy. If I'm going to destroy a subset of the configuration, I remove it from the code, and that implicitly destroys those resources. That's a smart way to handle it. I propose we skip the break since we're running behind. Shall we step into the lab?
Question on the Terraform. We're running this in the Docker container?
Yes. the first run. The next will be Azure, doing it in Azure DevOps. So now you are going to, from here, specifically that, see that? Remember we did a persistent mount to user local? And there are the actual files themselves. I always do an ls-la to make sure that there's no .terraform directories there or .terraform lock files. Upgrade is implied if you've never run Terraform init in this directory and you see it's going to download. I would encourage all of you to do this now because it's going to take a long time with this really high-speed internet at this hotel. I'm going to pause the recording.